Just maybe this material will be useful for other students. Here it is. Yeah, you see it. Here it is, the file that you send about laboratory work. It is connected with equivalent transformation star and triangle, initial data about variance. What does it mean? It means that you have for each variant 3 initial resistors that is connected as a triangle. And after that, you should replace them by the star and recalculate the values that this transformation should be equal. It means that you have this type of transformation, R1, 2, 3, 1, and 2, 3 as initial data. Also, you have electromotive force and 2 initial resistors here. That is mean inside this circle, A and B, it is the same view. A, it is how it should be implemented in laboratory if we have all offline classes. And the same equivalent circuit as we see it now just for mathematical calculation. And inside this circle, you have all the data. Let's see here. Voltages. These 2 files, they are from different laboratory works, because this file, I think, from the Kirchhoff law calculation, and this file about star and delta triangle. Just I finish about this one, and then we'll discuss what do you mean about this file. For this laboratory work, for laboratory work number 3, you should have all the data. If you don't have these 3 numbers, the teacher will give you. But in any case, 3 resistors from the table, 3 values from the second table, you have all data from the picture, and you should get the second picture after the calculation. You should recalculate star transformation, what resistors you should put here in the upper part of the circle to obtain the same equivalent circle after the transformation. It is the main idea. You should fulfill this table. Here it is. It means that you are pointing your initial data about triangle. Also, when you have triangle, you can calculate all these values theoretically, just because you have circle. Just because you have circle with all values. Here it is. Here it is. Points 1, 2, 3. Resistors between these points, because the difference in variance is the difference between these numbers. Then you're starting from this circle, for example, using mesh current method or just straight Kirchhoff's law, calculating all currents. You have 3 value of currents. I1, I2, I think it should be like that. I1, I2, and I3, 3 currents value, and voltages between points 1, 2, and 3, as it here. Fulfill the first table starting from this circle. Then the star delta transformation tells you that instead of these 3 delta or other word triangle elements, you can put such called star. The other 3 elements connected in the same point. And first of all, you have to find the value of these 3 elements. The value of these 3 elements and fulfill the table. How you could find it? Start using the formulas. They should be here. Yeah, Bethical theory. Oh, here it is. Here is the first part of formulas from triangle, because firstly you have triangle, to the star. You are putting these numbers as cherry colors. 1, 2, 3, these 3 resistors in the first formulas, and obtaining R01, R02, R03, the value inside star after the transformation, and fulfilling this column of the table. After that, also recalculating using or Kirchhoff's law or mesh current method, the new circle with new values of resistors. And after it, you will get also the numbers of 3 currents and voltages between points 1 to 3. And these values in the triangle and these values in the star, they should be equal, because these transformations are equivalent and the obtained working mode inside circle should be the same. That is why if you will obtain the same values in the table between voltages, all voltages between all currents, then you did everything well and you calculate everything right. Just these 3 steps. First step, your initial data. First step, to calculate working mode of triangle. Second step, calculate equivalent star to this triangle. And the third step, calculate working mode of triangle, star, to compare it with triangle. 3 main steps of your laboratory work. That is how it should be. Okay.
Professor, what about calculating the what's it called, the U and V?
Okay, we adjust values in volts. It is just volts and amperes. And how it should be calculating using the circuit model. Also, just one moment. Also, tutorial will be useful. Mm-hmm. Yeah, generally you should use any approach from the linear DC circle, we could find it from our lecture notes. It could be implemented, for example, mesh current method. It could be implemented, just one moment. Yeah, it could be implemented. The first hour calculation method, the mesh current method, or just the mesh method. Similarly, as we did previously here. For example, you could look on example 5.1 or 5.3 and did this calculation. Or I think the best explanation is here, or also in file with practical problems, the similar calculation should be, yeah, starting from page number 12 as mesh current here. It is just where you should see the details. How you should did the task in this lab is, as we're speaking about exactly this view of the circle. No problem, I will show about the first part and you will did by yourself at the second part. Because something in any case you should do by yourself. Okay. The first part, as you're asking about U12, it is connected with the triangle. Here it is. It means for this circle, you are searching from currents. For example, you could put currents inside mesh in any direction, let it be clockwise, let it called mesh current I11, I22, and I33. The idea will be to write the equations for these currents. After it, we could find currents 1, 2, and 3 inside the circle. And after this, we could find voltages 1, 2. How it should be written? For the first mesh, for the mesh number 1, it will be the mesh current inside it. Taking both of resistors. Also, there are the currents that flow through the resistors inside this circle. We are taking mesh number 1 and taking all currents that inflow inside the resistors on the mesh number 1. It will be additional currents 2 with negative sign because the direction is opposite. Current 1 will flow from point 2 to point 4, but current 2 will flow opposite from point number 4 to point number 2. That is why it will be with minus R1. And also the third current, I3, also will be with minus on the resistor R2. Just also hello students that connecting little later, we just discussed in the laboratory work number 3 because there was questions about it. And after that, we will continue on alternating current as we doing usually, as we finish previous class. Here you have electromotive force inside this mesh, and that's all. For the mesh number 1, it is complete finished equation. Then we are moving to the mesh number 2 and making the same equation for the second mesh. For the second mesh, the internal current is I22. You could point it. It should be also with plus. The internal current will be also with always with plus. You are multiplying on all 3 resistors. All that you have inside this mesh, R1, R2, and R23. And also external currents with negative sign because they are also flowing opposite direction comparing with the internal current. Then it will be minus I11 on the resistor R1, the resistor which is similar for 2 meshes, and also minus I33 and resistor 23 also a similar resistor between these 2 meshes. It equals 0 because you don't have electromotive force here. And the last mesh, the last equation for the upper part here, you're writing the own internal current I33 multiply on all resistors that you have. And minus both currents that are similar for these resistors. 1, 2, and current connected with the resistor 2, 3. The same as was here, 1, 2, and 2, 3, the same resistors. Also equals 0. It is your system with 3 unknown variables. And after the solution of this system, you should obtain the values of currents 1, 1, 1, 2, 2, 2, and 3, 3. You will get these currents. And after it, you will obtain voltages. After it, you will obtain, for example, voltages of 1, 2, 2, 3, and 3, 1. How it should be written? The voltage 1, 2, starting from the point 1 to the point 2. It will be the total current, and the total current is a combination current 1, 1 because it is the same directed minus current 3, 3 because it opposite directed, and multiply on the value of this resistor. It will be the formula for your voltage. Then the same for voltage to 3. From point 2 to point 3, it will be current to 2 minus current 3. And multiply on the value of resistor to 3. And the last one, voltage 3,1. It is opposite to the current 3. It will be minus I 3. Just multiply on the value of resistor 3,1. And you will get these numbers. That is just formulas to obtain these voltages. The same for currents. You could get current I1 as I22 minus I11. Currents I2 as opposite value to the current I22. And the last one, current I3 as value I11. Here it is. Here is the solution, how to obtain the numbers in the first row of table. Should I put the numbers? Should I show you how to solve this system, for example, in matrix form? Or you could do these steps by yourself? How do you feel?
I'm sorry, can you repeat what you said?
I just asking, I wrote everything in formulas. Can you solve this system by yourself mathematically? For example, using matrix form? Or should I put the numbers and show you solution just right now? Because then it's not a physics, it's just mathematics will be further. Putting numbers and solving this system. Should I do it now or do it later? Or you could do it by yourself?
Maybe if you can like solve one or something. Like add the numbers for one.
Okay.
And we can
Okay.
do this.
Okay. Then let's do it. It should be used some calculator. It will be useful maybe SMAT Studio or something like that. Maybe for cloud version. Okay, just one moment. I will save our drawing. And just one moment. Okay, yeah. Now it's working. SMAT Studio, for example, cloud version, you could switch to the English at the lowest point of website and starting the new calculation. We will need it for our solution. Then our formulas and fulfilling the numbers. First of all, we are making some matrix of resistors. Let name as, for example, R. It will be matrix 3 on 3 because you have 3 columns and 3 rows in each equation of this, in total system of this equation. Here it is. In first column, you should put R12 plus R1. Let it R1, let it be, for example, I don't know, 50. R2, let it be, for example, 100. Electromotive force, let it be, for example, 20 volts. And other will get from your variant other numbers. For example, let's build the last variant, 280, 800, and 500 for these resistors. Then, just to see it better, R12, 200, R23, 500, R31, 800. Because the numbers, it just depending on the variant, it's not so important what you will get. Then you are putting inside this matrix of resistors these points from equation, this coefficient from equations, as you have them here. Your 9 coefficients in this matrix. First coefficient will be R12, as you see, plus R1. Second coefficient will be R1. And last coefficient will be R12. Then it is R1. Then it is R1 plus R2 plus R23. Then it should be just R23. And the last one, R12, R23, and R12 plus R23 plus R31. And important thing, just not to forget on the signs, positive or negative, and put in minus in all parts that you should have this minus. Here, 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 and last 2 coefficients. Yeah, here it is. Put in enter and you get the value of this matrix of resistors. Also, you are writing the matrix of electromotive force, the right part of equation. Let it point, I don't know, let it name E with M as matrix. Should be matrix with 1 column and 3 rows. Okay, insert. Electromotive force, the first one, and 0 coefficient this. And then you could find currents. What you are doing? You could find currents. Why no? Okay. Currents value at the reversed form of your matrix multiply on the value of electromotive force. And just one moment. Just one small moment, sorry. Yeah, it should be the reverse matrix. Your current matrix multiply on the matrix of resistors equals. Sorry. I see what I missed. Because I named my matrix EM, not just E. I just multiplying on the coefficient, and that is why obtaining not correct value. Yeah, I point it as EM matrix, and I just multiply on the coefficient 20. EM multiply on your reverse matrix. That was missing part. And okay, the dimension, it should be R minus 1 on the value E. EM. Okay, matrix form. Yeah, here it is. The value of current that we are searching for. Why it is so? What we did, we have currents that multiplying on the matrix of resistance, matrix of currents multiplying on the matrix of resistors, and obtaining matrix of electromotive force. Then EM. Then you could multiply on the reverse matrix here and here. And reverse matrices will give you 1, and that is how you obtain your current. The current value will be multiplication of reverse matrix on the electromotive force matrix, and it will be your solution. That is mean that currents inside this circle equals 102 milliamperes, 25 milliamperes, and 22 milliamperes. The value that flowing inside your circle. And for these numbers, how it could be get your current that you are searching in the circle that we write previously, the current I1, or just see, okay, just thinking how it will be better, let it be like that. Current I11, let it be our matrix and first element. Here it is. Then our current I22, it will be our matrix, putting here the second element, and I33 equals I matrix, the last element. Here it is. And substituting voltages on these formulas, we 1,2 equals, as we write, I11 minus I33 on R12, 16 volts, V23 equals I22 minus I33 on R23, about 1.5 volt, and V31 equals minus I33 multiply on R31. Here it is, minus 17.5 volts. And how we could check that everything is okay? Because these 3 voltages making the whole circle, then according to the second Kirchhoff law, they in total should equals 0. And as you see, they in total equals 0. Everything is okay. That is your calculation that could be implemented for any variance, because here you have system, and or you solve this system and obtain all numbers in total. You cannot just find only one sum value. You should find everything that you have. That is why we did everything and find all voltages. For the currents, I wrote previously how to find these three currents connecting with the mesh currents. When you know mesh currents inside the mesh, you could find the currents I1, I2, and I3. That is about this work. After you fill in this first row of the table, you are making the calculation for the start for this variant. But here it will be much simpler because you have only two meshes, only one source, and it could be made much easier. You could just summarize resistances. The current I3, it could be found as electromotive force divide on the total resistivity, and the total resistivity is R01 plus parallel connection of your elements. Parallel connection of R1 plus R02 and R03 plus R2. And adding all these numbers all together. After you find I3, the same idea. You could find I1 and I2, and you could find voltages between these points just using currents. For example, I3 on R01 minus I1 on R02. The second circle is much easier. It's much quicker for calculation than the first one, because in the second circle, you have only two meshes and elements are serial between each other. Something like that, how it should be implemented in the third laboratory work. Please, if any further questions, please welcome.
Professor, can you bring the other answers? The other part?
Yes, in any case, I will download this video for you. I could also make a screenshot of these calculations. But okay. Just to send it to you. Okay, but in any case, using this video, you could take in the online calculator and substitute, make equations and substitute the right numbers according to your variant and try to solve this once more by yourself. Yeah, but in any case, I will send these photos and the video of whole lecture.
Okay, thank you, Professor.
Okay, you're welcome. Okay, maybe other questions, please. Okay. Then let's discuss a couple of points on the alternating current as we have time. And for the next lecture, also, if you have any questions, please welcome, because your main task, your main goal to finish all practical works with teacher Ludmila and all laboratory works with teacher Olga, to pass all these individual tasks, to obtain the necessary points, and to get the final score for this discipline. That is why if you will have some misunderstanding, please welcome, we could discuss it also on lectures. Then about alternating current, what we finished previous time. We finished, we passed about elements. We told that have three main elements: resistor with sinusoidal form like this, with vector graphical form of complex vector like this, without any angle between voltage and current. Then for the coil, shifting on plus 90 degrees and between sinusoidal functions and between voltage and current. And for capacitor, the opposite situation. For the capacitor, shifting minus 90 degrees between current and voltages. Voltage lags on 90 degrees from current, that means that current leads. And the angle is minus 90 because current leads instead of voltage. Also, we discuss about resistances, that for sinusoidal current in complex form, the resistance of capacitor, it is graphically depends from frequency 1 over omega c, and for coil, the graph will be straight line because it equals just omega multiply on L, the resistance of coil. Also, we obtain the table with main characteristics of these three main elements, discuss all laws, discuss that current Kirchhoff law could be implemented or in sinusoidal form or in form of complex vectors. It is true. It is the same as for direct current. Everything is okay. Then we discuss the same law about voltages, that for then or in sinusoidal form or in form of complex vectors, the total voltage inside mesh will equal the total electromotive force. And we moved to the serial and parallel connection of elements, and discussing that if we are connecting elements in serial R, L, and C, the voltages should be added between these elements. And in general sinusoidal form, because for coil, general equation as derivative from current, and for capacitor, the general equation is an integral function of current. In sinusoidal form, we will get equation like this, with positive shift angle for coil and negative shift angle for capacitor, and with resistances omega L for coil and 1 omega C, 1 over omega C for capacitor. And after transforming it in complex form, for serial connection, the total voltage on whole three elements will be just Ri as Ohm law for resistor plus JXLI as Ohm law for coil and minus JXC on current I as Ohm law for capacitor. The capacitor always will be negative, the coil always will be positive. And as total, we obtain the value such called impedance, the total resistance that multiplying on current, and the dependence between voltage, current, and the impedance value, it is also implemented as Ohm law, as total resistance of whole 3 serial connected elements. Then, because voltages is making a triangle with 90 degrees angle, if we will point all vectors, voltages, and currents on our diagram, we will obtain the triangle with 90 degrees angle. Why? Because for resistor, the way for resistor, as we discussed previously, current and voltage should be the same vector. If we point total current, the voltage is here. For coil, current and voltage is making 90 degrees angle. Also, we discussed it previously. Here it is, current and voltage as 90 degrees angle. And for capacitor, I will draw it here. For capacitor, current and voltage should make minus 90 degree angle. Here it is, current and voltage, minus 90 degree. And in total, coil and capacitor voltages are serial connected between each other, and it will be on the same line. And we have as one part of triangle and the second part 2 voltages and a hypotenuse, the total voltage on the serial connection. That is why we could use Pythagoras theorem between these voltages. Also, we could use Pythagoras theorem between resistors, resistances. The same for R and X as difference between coil and capacitor. And the impedance value that the value, the angle will be the same as in triangle of voltages. And it gives us mathematical apparatus for transformation for using Pythagoras theorem to calculate in voltages, resistances, and angles, and working with complex value for serial connection. It is quite useful. It is called the triangle of resistances for serial connection. And I think for today, our time is finished because it's 10:05, 5 minutes after 10. I think according schedule, the lesson is finished. But the next time we will continue forward with parallel connection, and we'll get the same value of triangle of conductivities. Also quite useful thing for parallel connection. I think it is here. And we'll speak a little bit about powers. Just all these mathematical apparatus, it will be useful for sinusoidal current when you will move to it on the practical and laboratory classes. Just like that. Okay, any questions to me? Maybe you want to ask something?
No, no, Professor.
No? Okay, then was glad to hear you. Thank you for your attention. And for today, that's all. Wish you a nice day and see you next time. Goodbye.
You too. Thank you. Have a good day. Goodbye.
Thank you. Thank you. Goodbye.